Hi and welcome to the Unquendor Guitars workshop. My name is Daniel, and if you're experiencing problems when soldering your guitar components, keep watching this video because I'm going to share all my tips and tricks to make the soldering process a whole lot easier. I don't spend a lot of time on Facebook groups and guitar building forums and such, but when I do, I often see questions regarding soldering. So I thought, why not make this tips and tricks video for you guys. So let's start by taking a look at some of the equipment you need for soldering and some of my recommendations. Let's start by taking a look at the different soldering irons. They come in a variety of sizes, shapes, all with different power. The bigger they are, the stronger they are, and I go over why that's important in just a moment. And besides these simple plug and play soldering irons, I do recommend getting yourself a soldering station. The main challenge in soldering is getting the heat transfer from your soldering iron to the components you're trying to solder as quickly as possible. And that's when the power of the soldering iron comes into play. When your soldering iron is too weak, it can't keep up the heat sink from the tip of your soldering iron to your components, making a very cool and not hard enough joint, and it can take ages for your components to heat up and your solder to actually melt and get a nice transfer of solder on your components and your wire. So that's why you need a powerful enough soldering iron. So a 15-watt soldering iron is not strong enough usually for soldering guitar parts. It's very useful for soldering small joints like on PCBs. The big hefty one, on the other hand, is too powerful. It's too clunky to move around in your control cavity, and the chance of you burning your wire or the internals of your components is also a bit higher. So I use this one, for example, for heating up frets when I'm doing refret work. So now let's focus on the soldering station, and they're a bit more expensive than the regular soldering irons, but still very affordable, especially if you don't go for the high-end stuff like the Weller soldering station. But this is a CFH soldering station, still very affordable. It's a 45-watt soldering station, and the main benefit of a soldering station is that you can very accurately set the desired temperature, and I recommend a temperature of around 375 degrees Celsius. And you can see when it's heating up, and with the readout you have some confirmation on how hot your soldering iron is. Soldering irons come with a variety of tip shapes and sizes. You have these very pointy tips and these broad flat tips called chisel tips. When soldering, like I said, we're trying to transfer the heat from the soldering iron into the components we're trying to solder as quickly as possible to not overheat the entire component, but still get it hard enough for the solder to flow and adhere to the components. So I recommend using a chisel tip because of the large surface area. The larger the surface area, the easier the heat will transfer from your soldering iron into the components. But of course, when soldering smaller components like the push-pull pots or maybe even PCBs, you can use a small tip. And the nice thing about my soldering station is it comes with a replaceable tip. So if needed, I can switch between a chisel tip and a pointy tip. And now, while I'm talking about the tips of the soldering irons, make sure it's nice and clean and has a small coat of the soldering tin. And I'll show you how to achieve that in a moment. So let's take a look at the soldering tin you might come across and things to look for and things to avoid at all cost. First things to avoid is the soldering tin usually sold in hardware store or home improvement stores in the plumbing section. These types of soldering tin are used for copper piping and such, and are not used and not suitable without any additional fluxes or soldering fluids to be used on electronics and guitar components. These spools are usually bigger spools. The tin has a bigger diameter and you should avoid these at all cost. Things to look for is specialized soldering tin for electronics, usually sold in stores like in America the Radio Shack or electronic stores and such. Sometimes home improvement stores or do-it-yourself stores might sell these, but things to look for is that it says on the packaging that it's used for electronics, like this one is used for PCBs and this one says it's used for electro. They come in different alloys. This is a tin lead alloy, 40% tin, 60% lead. And for the PCBs you usually have a higher tin content, it's 60% tin and 40% lead. They both work fine. And one other thing to look for on the packaging, besides it's saying electro, is right here, and usually on all the packages it says it has a resin core. And this resin core helps the tin to flow from and to your components and your wires. However, in some countries lead is banned to be used from soldering wire, and it's replaced by silver. And this is, for example, a spool of tin silver soldering wire. Both work perfectly fine. However, when using a silver tin alloyed wire, your heat transfer and your heat management on your components becomes much more important, because it takes a while longer for the silver to flow in comparison to lead. But I'll show you in a moment that when you solder correctly, you shouldn't notice any difference between a silver tin alloy soldering wire and a lead tin alloy. When soldering, you want your soldering iron to be powerful and hot enough to quickly melt your soldering wire and heat up your components, but without burning your components. So I recommend a temperature to be set on your soldering station of 375 degrees. When the soldering iron is hot enough, it's time to make sure we have a nice and clean tip on our soldering iron, and you can achieve that by using a damp sponge and really wipe the tip of the soldering iron, and then apply a little bit of the soldering tin to both sides. You got a nice drop on the end. Wipe it clean. And repeat this a couple of times. Besides using a good quality soldering iron or soldering station with a nicely cleaned tip and the correct soldering wire, another issue with soldering often is moving components. You don't want your components or your wires to move at all, both to help with the heat transfer from your soldering iron to the wires or the components you're trying to solder, and also while the joint is cooling down. When you move a wire or a component too soon when the joint is still cooling, you might have a slight chance the joint will crack, giving a bad connection. So it's advisable to look into some holding solutions like these helping hands, just 2 clamps, fully adjustable, which you can use to align the joint and make your connection, or make yourself a little jig, for example in the same configuration as your control cavity, in which you can place your components and keep them nice and tight while you make your solder connections. I made mine with these little posts in the back that have a little slit, and I can also use these to hold down wires for soldering. You always need to pre-tin your wire ends, and it's easily done with the heated soldering iron. Just apply a tiny bit of the solder to the tip, heat the wire from underneath, and now the heat will transfer up into the wires. And as soon as you see the tin being soaked up by the strands of the wire, apply a tiny bit more tin, and now you have a perfectly tinned wire end. There are basically 2 methods you can use to solder a wire to your pot. And the first one is to pre-tin the lock on your pot by heating one side of the lock and applying some tin to the other side until the lock is nicely filled. And then with your pre-tinned wire, reheat the lock from the back, insert your wire, heat it some more, and let it cool. And this gives you a nice solder joint. The second method is by inserting your pre-tinned wire into the lock you're trying to solder to, and arrange the wire in such a way it doesn't move, and then heat both the lock and the wire with your soldering iron. Tiny drop of soldering tin until you see it flow, and now you've got a nice connection. Now let's do the same but with a silver tin alloy. So exactly the same, a perfect soldering joint. And here's another example of what you're looking for in a good solder joint, and that's a nice and even transition of solder between the lock and the wire, and it's somewhat shiny. And although I applied heat and tin only to the inside of this lock, because I heated it perfectly, the solder transferred all the way through to the other side of the lock, and this is a nice and solid solder connection. To solder a ground wire to the back of a pot, and this is where most people struggle, I like to do it near the edge of a pot because there are no vital parts there I can potentially damage with the heat from my soldering iron. But what I do is first I apply a bit of the tin to the back of my soldering iron and start applying some heat to the back of the pot until I see it, the tin starting to flow, and then I apply a bit more until I have a nice drop of tin to the back of the pot. No need to scratch or sand the pot like some say, just make sure you have a nice heat transfer from the tip of your soldering iron to the back of the pot. Now take my little wire, reheat the drop, insert my wire, and I'm done. So, and to solder two wires together, I just twisted them around each other. And what I like you to take notice of is the way in how the solder flows through these wires. Again, I'm using a silver tin alloy. I just apply a drop of the solder onto my soldering iron, start heating the joint until I see the tin is being soaked up by the wires, and then I start applying some more from the top until it's nice and evenly coated. So I hope you noticed how the soldering tin flowed into these wires, and that's something to look for on all solder joints, whether it's a wire connection or a connection from a wire to a pot. And there you have it, my tips, tricks and methods of creating the perfect solder joints on my guitar components. But before we go, let's do a quick little recap. Of course, start by getting a good quality solder iron, preferably a soldering station, so you can set the correct temperature and you can manage the temperature of your soldering iron. Use a small chisel tip on your soldering iron and make sure it's nice and clean and has a tiny coat of soldering tin for each and every joint. Make sure you have the correct soldering tin. It could be a silver tin alloy or a lead tin alloy, 60-40, 40-60, it doesn't really matter, as long as it has a resin core to help the flow of the soldering tin onto your components. Also, make sure your components don't move during soldering and while cooling by making use of a little jig or these helping hands. So that's basically all there is to it. I hope you got some value from this video, and if you did, let me know in the comment section down below or by hitting that like button. If you're new to my channel and you like my style and you like what you've seen, please check out my channel, and yeah, you can also subscribe to don't miss out on any of my future tips, tricks, tutorials or full guitar build videos. So yeah, I hope you liked it. Like always, I hope to see you in the next one, but until then, have a nice week.